A metallic object just crossed between Mars and Jupiter. It slowed mid-flight, changed direction, and radiated heat. None of which natural objects should do. JWST caught it all. It's not a comet, not an asteroid, and it's emitting signals. Whatever it is, it's here, and it's moving with purpose, discovery, and first anomalies. It started with a flicker, a strange, unassuming dot in the darkness. The James Webb Space Telescope was conducting a routine scan of the asteroid belt, the space between Mars and Jupiter. Day after day, JWST captures data on these rocky bodies. Thermal readings, motion tracking, material composition. It's precise work, methodical, automated, and usually predictable. But this time something stood out. A small object drifted into view, but its path wasn't normal. Unlike everything else in that region, it wasn't following a standard orbit. It was veering slightly, almost imperceptibly at first. Then it did something that made scientists sit up. It slowed down mid-flight. Objects in space don't decelerate unless something makes them. Everything we know about orbital dynamics, Kepler's laws, and Newton's gravity suggests a rock in space will keep coasting forever unless acted upon. That's what makes this discovery so startling. As one control room scientist said, "We don't see space rocks slow down. That just doesn't happen." What followed was a cascade of double checks. Was it a sensor error? A false return? The JWST team scanned again, still there. They pulled radar data from other facilities. Same result. This wasn't a glitch. The object's trajectory had changed. And that kind of maneuver, even if slight, hinted at something else entirely. Then came the spectral scans. JWST observed the object across multiple infrared wavelengths to identify its composition. What it revealed was even more baffling. The object was metal-rich, and it was retaining heat far more than any natural body of that size should in the cold shadow of space. Most asteroids in the belt reflect sunlight. This one didn't just reflect, it glowed. Its heat signature suggested internal warmth, not just surface heating. And then there was the noise, a faint electromagnetic signal, narrow band but consistent, barely above the background noise. It wasn't strong enough to be communication, not yet. But it wasn't natural either. Within hours, JWST's data was sent to other observatories. A cross-instrument verification process began. Telescopes in Hawaii, Chile, and Australia locked onto the coordinates. Every one of them confirmed the same bizarre behavior. It was real and it was active. What had started as a passive scan of an old familiar region of space had now become a full scientific alert. Something had arrived or perhaps awakened between Mars and Jupiter. It didn't belong there. And it wasn't just drifting. It was acting. We thought we had mapped this neighborhood. One mission analyst said, "Now we're realizing there might be visitors in it." And that realization brings us to the next question, not just what this object is, but what it isn't. Before scientists could even begin to speculate what the object might be, they had to rule out what it clearly wasn't. In the asteroid belt, most bodies fall into well-known categories: C-type, S-type, or M-type asteroids. These classes correspond to carbon-rich, silicate-rich, and metal-rich compositions, respectively. Each has distinct spectral fingerprints, and we've catalogued thousands over decades of observations. This object didn't match any of them. First off, it had no ice content. That immediately ruled out comet-like objects, which usually trail faint gas emissions or water vapor when exposed to the sun. There were no volatile elements detected, nothing that hinted at frozen bodies shedding material as they traveled. So not a comet. Next, scientists looked for signatures of typical asteroid minerals, carbonates, silicates, or iron-rich surfaces. But instead of familiar peaks and dips in the spectral data, this object returned a baffling pattern. It contained unusual absorption lines and emission peaks, not tied to any known meteorite class or natural mineral set. No known space rock produces this kind of chemical print. The most revealing clue was thermal inertia, how the object handled heat. Natural asteroids heat up when they face the sun and cool down quickly when they rotate into shadow. This object didn't cool down like it should. Instead, it retained heat, glowing softly in the infrared even after hours in the dark. That's the behavior of engineered materials, not porous stone. Rocks cool quickly. One thermal analyst said, "This thing cools like steel, slowly, deliberately." It was also emissive, not just reflective. Most natural bodies in space reflect sunlight. But JWST observed this object radiating its own warmth. That means it wasn't just passively heated. It had internal warmth. Maybe a heat sink, maybe a reactor, maybe something else entirely. Whatever it was, it broke the pattern of natural cooling cycles. Even its outer layer seemed alien. The surface spectrum didn't match metallic meteorites or even rare solar system alloys. No one could find a match in the spectral libraries maintained by NASA or ESA. It didn't resemble any recovered meteorite, nor any known space junk or satellite debris. In short, this was not a fragment of a planet. It wasn't a comet. It wasn't a known asteroid. It didn't belong to any known probe. And it certainly wasn't space junk. Its shape and material reflected a level of organization, or at least composition, that nature doesn't produce on its own. "We've catalogued the solar system's chemistry for decades," said one spectroscopist. "This isn't just unknown. It's inconsistent with natural formation." The object's oddity wasn't just in how it looked, but how it behaved. And that takes us to the most unsettling part of the story. It was moving like it knew where it was going. Motion and trajectory, behaving like something alive. Space is quiet, still, predictable. Objects follow gravity like clockwork. Planets orbit stars. Asteroids loop in stable arcs. But this object defied that script. Its movement didn't fit any gravitational model. JWST recorded not just a deceleration, but a course correction. It shifted laterally like a spacecraft making a minor adjustment mid-journey. That kind of maneuver simply doesn't happen on its own. There were no planets or moons nearby to cause a slingshot. No visible collisions, no outgassing, just pure directional change. Intentional, subtle, and steady. Multiple instruments tracked it over days, and each time the object exhibited signs of controlled navigation. It would slow, reorient slightly, and continue. These weren't dramatic turns, no wild zigs or zags, but they were deliberate. The changes didn't align with the influence of the sun or any known solar wind effects. Scientists ran simulations. Gravity alone couldn't explain it. Even solar radiation pressure used by some spacecraft, like light sails, couldn't account for the pattern. The direction of the object's shift didn't match the way radiation would push it. The data didn't show a drift. It showed decision-making motion. Other observatories joined in. Goldstone radar picked up tiny, consistent shifts in velocity. ESA and JPL confirmed the same signature. This was not an inert body. It was steering. "This isn't how passive objects move," said an orbital analyst. "It's making choices." And those choices became even more profound when you consider where it was drifting, right through one of the most stable zones in the solar system, the asteroid belt context. Why this stands out? The asteroid belt between Mars and Jupiter is not chaos. It's order. Thousands of bodies orbit in neat gravitational lanes. We know where they are. We know where they're going. They don't just appear out of nowhere. This object did. The belt is filled with everything from dust particles to dwarf planets. These bodies fall into families, clusters of fragments from old collisions. Some are locked in orbital resonances with Jupiter. Others gather in Trojan zones, where gravity from the Sun and Jupiter balances out to create natural parking spots. JWST and other missions regularly observe these patterns. They're like traffic lanes in deep space. This object didn't follow any of them. It entered the belt on an unclassified vector, crossing paths with known bodies, but without joining any orbital group. And more disturbingly, it passed through gravitationally stable points, regions where natural objects would either get trapped or flung out. But it just kept going smoothly, unbothered. Even metallic asteroids, rare, dense, and strange, have predictable orbits. One of the most famous, Psyche, is believed to be the exposed core of a failed planet, but even it obeys gravity. This object didn't just ignore the rules, it rewrote them. And that made scientists re-examine everything. Its heat, its motion, its trajectory, they all suggested something designed or at the very least non-natural. And if it wasn't natural, then maybe it was something else entirely. "We thought the asteroid belt was a closed book," said a planetary researcher. But now a new page has turned. That new page takes us deeper into the data itself, into the light this object reflects, absorbs, and emits. Spectroscopy, thermal inertia, and EM signature clues in the data. The deeper scientists looked, the stranger the object became. Spectroscopy, Analyzing the light emitted and absorbed by the object revealed a signature that didn't fit anything in existing catalogues. The lines didn't match carbonates, silicates, or iron oxides, the usual suspects in asteroid composition. Instead, they hinted at complex metallic alloys, possibly engineered or refined, not formed through random planetary processes. One of the most telling clues came from thermal inertia measurements.